Hello, welcome. Let's have a quick one on this. We have this grid showing the graph. So they say the diagram shows the graph of a linear relation of the form y equals to mx plus c. We have to use it to answer these two questions. Question 1, we have to find the slope of the relation. And the question 2, we have to find the equation of the relation. This is BECE 2024 objective test question. So let's look at it. So this is the straight line whose gradient we are asked to find. The gradient is the slope, which the question 14 is asking. Now, to find the slope of this, we have to understand that for a straight line, we have the direction of the straight line determine the nature of the slope. If the direction is, if this is our Cartesian plane, then we have the direction is passing this way. We know we are having a positive gradient. That is, the straight line passed through either the origin or any direction, starting from the left lower to the right top. Will give you positive gradient or positive slope. Then if the gradient or the straight line is passing this way, we also have a negative what? Gradient, which is going to be in the case of this. This is going to give us a negative gradient because it is coming from left to right, top to down. That will give you a negative. We also know that if we have it this way, that is, the line is vertical or is parallel to the x-axis, this is undefined. This is going to be undefined gradient. And finally, the gradient that has a line or a straight line that is parallel will give you zero gradient and undefined gradient. So these are the four types of gradient or nature of gradients that we have depending on this. So even if I don't want to follow any criteria, I can tell that this is going to give me a negative gradient. All right. Now, in doing so, we need to draw a right angle triangle using the straight line as a hypotenuse. Then we find the change on the y-axis to the change on the x-axis. We always have to locate the corner where the straight line is passing through a point that is at the corner. So I can indicate this place as a corner. I can also indicate this place as a corner, or better still, I can indicate here. Any aspect you pick, I am going to indicate here to make it a smaller. You see, this is the right angle I am going to pick. You can also pick it from here, end it on this, bring it to this place. We can also have another corner. If this one continue to go, it may also pass through this corner. So you can pick that corner and this corner. We have it here as well, a corner to the tree, a corner to this place. As long as it's a right angle triangle with the hypotenuse being the straight line, we are good to go. Now you see that in the drawing, I went from top to down. So top to down, meaning from 3 we are moving down. That will give you a negative movement. If we can also say, we can say gradient or slope. Let me just say, slope can also be a rise or a run, which we can take as what? The change on the y-axis over the change on the x-axis. You can see that this one, we say rise. We are not rising, we are falling. So if you are rising, it will be positive. Now that we are falling, it's going to be negative. So the fall, we fall 1 unit, 2 units. So that's going to be negative 2. Then we run. How many units? We are running 1 unit. So that becomes 1. That gives us negative 2. So the gradient of this relation is minus 2, which is the slope we are looking for here. So our slope will be minus 2. All right. Then for the question 15, which is the easiest one, we have to find the equation of the relation. And this equation would be in this form, meaning the y and the x will still be part of our equation. The m is the gradient which we found here. The c is the intercept on the y-axis, meaning where does the line cut the y-axis. The y cuts the line, The line cuts the y-axis here. So that means the y-intercept is going to be 3. So our equation will just be y equals to m, which we found as minus 2 times the x plus c, which we just found as what? 3. So this is going to be the equation. No need to perform any calculation again. You just find the intercept on the y-axis. Where does the line cut or cross the y-axis? That value is the intercept. Because if you were to pick any point and substitute in place of x and y using the gradient, you still get the y, the c to be equal to 3. I'm sure the concept, how we get the gradient and the equation, is perfectly understood by you. If that is true, then share with somebody. Don't forget to subscribe on YouTube, follow us on Facebook, TikTok, and God will bless you. Bye-bye.